All right, guys, this is Wednesday, April 29th. We're going to be covering a topic today called mean absolute deviation, which in simpler terms is we're basically just figuring out how far away on average each number is away from the mean. So on average, how far is each number away from the average, I guess is another way we could do it. The problem I'm going to be working on, it's several steps, so we're just going to do one. We're going to take it slow. I encourage calculator use. It will help you with the frustration level, I do believe. Page 838, towards the very bottom, there's a question on the speeds of the top 10 fastest birds. So in a moment, that's where we'll be starting. Wanted to share with you, I just came outside. It's 100 degrees, a little toasty, but on the news, the police reported that they had just arrested the world's tongue twister champion. The judge says he's going to give him a really tough sentence. All right, so I've taken the information on page 838 that was in that table. I did order them left to right, at least to greatest. Just a habit, I think it's a good habit to get in for when you're doing this, but since we are only dealing with mean, the reality is it doesn't matter that you order them today. You could just define the mean. Remember, we add them all up and divide by however many numbers it was. So you could just do that. I just like to put things in order like this. So I expect a lot of starting and stopping, but with the video today as I kind of skip to each new step. So step one, we are going to add all these up, and then we are going to divide, I believe it was by 10. I think there was 10 numbers, and that'll start us off by giving us our mean, which is always going to be the first step. Find the mean. All right, so I went ahead and added all those numbers up using a calculator, and I got 700. I'm trying to reach all the way around the camera here. I got 786, and we're going to divide it by the number of numbers in the set, which was 10. Now, I bet you remember back when we did all the place value stuff that I don't actually have to work out. When I'm dividing by 10, I could just move that decimal one place to the left. If I was dividing by 100, I could move it two places to the left. So that's convenient since we're dividing by 10. So I'm just going to go ahead and slide that decimal over one. So that means our mean is 78.6. So that's always going to be step one when finding mean absolute deviation. Now, here's where the tedious part comes. We now have to find the difference or distance between the mean, 78.6, and each number in our data set. That means I got to subtract 10 different times, 78.6 minus that, 78.6 minus that, 78.6 minus that, and so on. Now, remember, some of these numbers, since this is our average, some of these numbers are actually going to be greater than the mean. Since it's absolute, we don't care about positive or negative. So if you're doing it in a calculator, you could do 78.6, take away 80. You are going to get a negative number, but just remember that negative doesn't matter since it's absolute value, and absolute value is just the distance away from zero, and the positives and the negatives do not matter. Or you can do it like I do it, which is once the numbers become greater than the mean, I just flip the problem. So I'll do 80 minus this, 88 minus this, 95 minus this, and so on and so forth. Let me stop it and get it all set up. All right, so this gives you an idea of how I like to set it up. You can see the mean's been repeated over and over, and I'm just subtracting away each one of those numbers from our data set each time so I can get the distance away from the mean that every single number is. You also notice as the numbers suddenly got greater than my mean, I started just flipping it. So this 80 up here, I did 80 minus 78.6, 88 minus 78.6, and so on and so forth. Since you're using a calculator, you can do it either way. Just remember to ignore the negative sign. So now I'm going to go through and subtract all these. I'll just do one or two for you, and then I'll pause the camera. So 78.6, and I'm going to subtract from it 65, and I get 13.6. And then since the next one's the same thing, I know it's going to be 13.6 again. Then I'm going to do, once again, 78.6. And we're going to subtract from it the next number, 68, and I get 10.6. And it seems like a good time to pause. I'll be back with you after I've done all that. All right, so there you have it. I've found the difference. Remember, these differences are just a measure of how far away every number in our data set is away from that mean. Now, we want to know the mean absolute deviation, which means we want to know what is the average distance that these numbers are away from that 78.6, which was our mean. And you remember when we find average, when we find mean, we add them all up and we divide by however many numbers there are. So we're gonna now, said this is tedious, right? We're now gonna add all those numbers up and we're gonna divide it by 10. Oh boy. All right, so we're almost home here, guys. I've added them all up. I got 109.2. Now remember, to get the mean, we'll divide it by how many numbers that was, which is 10. Again, since we're dividing by 10, we can use our rules and we can just slide that decimal one place over to the left, which gets me 10.92 miles per hour. So that means on average, our bird's speed of flight is about 10.92 miles away from the average of the entire set of data, which means, in my opinion, it's pretty tightly packed in there. It's you know, we don't have a huge difference between at least the top 10 birds. Now, you know, if we threw a penguin or a chicken in there, I don't even know if what they can do even counts as flying, but that would probably give us a little bit bigger absolute mean, or mean absolute deviation, wouldn't it? Because then we'd have some really low numbers in there. But I hope you enjoyed. I do apologize, but please use a calculator. It'll save your sanity, I do believe. So give it a shot, guys. And hopefully the temperatures come down, because it's a little warm on the deck.